Hello, everybody. So for the last couple of days, we've been looking at finding the slopes of tangent lines using a limit. And so that the process of finding the slope of a tangent line is called the derivative. So from now on, instead of saying the slope of the tangent line, we'll simply say derivative. So the derivative of a function is um, an equation that can give you the slope of the tangent line. And the notation for the derivative, if we want the derivative of f of x at x equals a, we'll simply write it as f prime of a. So when we plug in a number for a, that gives us a slope. And so we can think of it this way: slope equals f prime of a. So for the first example, we have f of x equals x squared minus 2, and we want to find the equation of the tangent line at x equals -4. So that means we need the slope of the tangent line at -4. So that's going to be called f prime of -4. So f prime of -4, using the limit that we learned, limit as h approaches 0, we're going to do f of 4, that is -4. Here, I'll write it out with variables first. So this is what we've been doing: a plus h, f of a plus h minus f of a over h. So in this case, a equals -4 because that's where we want to find the derivative or the slope. And so that's going to be the limit as h approaches 0 of f of -4 plus h minus f of -4 over h. So now if we plug those expressions into the function, that's going to be the limit as h approaches 0. F of -4 plus h is going to be -4 plus h quantity squared minus 2. And then minus f of -4 is -4 squared minus 2. And then all divided by h. And so if we simplify up on top, we have h squared minus 8h plus 16. That's if you multiply this out. Remember, to do that, we're doing h minus 4 times h minus 4. So that's how I got h squared minus 8h plus 16. Then minus 2. And then looks like we have minus 16 minus 2. And so if we get done simplifying everything up on top, we have h squared minus 8h, and then this is 14, and this is 14. So it's 14 minus 14, which is 0. So that numbers are all gone. And then we just have h squared minus 8h over h. And so now we can factor out the h in the top. And as I've mentioned before, you should have all the constants cancel like we did here, the 14 minus 14. Whenever you do these problems, the constants should cancel every time, and so that you can factor out an h and then cancel the h. Now I have the limit as h approaches 0 of h minus 8, and that answer is -8. So that is our slope at -4. So remember, we're saying f prime of -4 equals -8. So that means the slope of our tangent line is -8. Okay, so we're not done with the problem yet. Now that we found the slope of the tangent line using the derivative, so this whole process now, we're calling that using the limit to find the derivative. So derivative again just means slope of the tangent line. Okay, so all that led to this, which is the slope is -8, and now we need a point. We have a slope. Now we need the point. So when x is -4, if we go back to the original function, that is 16 minus 2, which is 14. So our point is 4, 14, -4, 14. And so using point slope form, that would be y minus 14 equals negative 8 times x plus 4. So then we have y equals, you could leave your answer like that. That is correct. If you wanted it in slope-intercept form, that would be negative 8x minus 32 plus 14 when you add 14 to both sides. So that could also be written as y equals negative 8x minus 18. So those are both the same line. It doesn't matter which form you put it in. Those are both correct. Okay, so that example is really the same as what we were doing in the last lesson when we were finding slopes of tangent lines. The only difference is that now we have this derivative notation and the concept of a derivative. And so from now on, we just need to remember when we hear the word derivative, that really means the slope of the tangent line. So we didn't really do any different mathematics here. We just gave it a different name. We called it f prime of negative 4, but it's really just the slope of the tangent line at negative 4. Okay, so now that we have this concept of a derivative, we're able to find the derivative in general, which means to get an expression in terms of x. So then we would, once we have an expression in terms of x, we would be able to use that derivative to calculate the slope at many different values. So you'll notice that the definition of the derivative here is no different than the limit that we've been using, except in the previous limit we always had a plus h minus f of a. Well, now we're just doing it in terms of x. And so in place of all the a's, we're just leaving the variable x. The calculation is very similar. It's just that we're going to have a variable there instead of a bunch of numbers and h's. So we're going to go ahead and do, we're going to find f prime of x, which means we're going to find the derivative. So remember, when we see this, that means the derivative of f of x. And so if I use this new limit that we have, we would say f prime of x is equal to the limit as h approaches 0. We're going to do f of x plus h minus f of x over h. And so then when I substitute x plus h in place of this x and this x, that's going to be x plus h squared minus 2 times x plus h minus f of x. And f of x, normally we have a number in there and we just plug the number in, but now we're just plugging x in place of x. So we still have just x squared minus 2x. So I put that in parentheses because it's important that we understand we're subtracting f of x. And so we have to put everything that is contained in f of x inside those parentheses. Okay, so this should look just like what we did earlier in this lesson, except earlier we had a number here. We had 4 in place of h and negative 4 here and negative 4 here and so on. So now we're just going to have x's instead of those numbers. And so now when I expand, I get the limit as h approaches 0 of, if I expand this, that is x squared, excuse me, plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x. So I've got that big long expression. And so now we're looking for some things that might cancel. For example, I see 2x, negative 2x and positive 2x. Those cancel. I see an x squared and a negative x squared. Those cancel. And so now I have the limit as h approaches 0. We have 2xh plus h squared minus 2h all over h. And we notice again that we can factor out an h just like we were able to do in the previous problem. and you should always be able to if you did all the expansion correctly. Then we can factor out an h, and that is going to leave us with 2x plus h minus 2 all over h. And those h's cancel. So now we have the limit as h approaches 0 of 2x plus h minus 2. But remember, h is approaching 0, so that means this is going to approach 0. This term is going to approach 0, and all we have left is 2x minus 2. And so that is our derivative. So that is typical when we did the, like in the previous problem when we found f prime of negative 4, we ended up with a number as an answer. F prime of negative 4 turned out to be negative 8. And so now we have an expression, f prime of x turned out to be 2x minus 2. So we're done with that, but I just want to explain what we did and what we can do with this derivative now that we have it. So now that I have this derivative, if I want the slope of f of x at 3, for example, that would be f prime of 3. So now that I have a derivative function, I can just plug in right here in place of the x. So that would be 2 times 3 minus 2, which is 4. So now I know that f prime of 3 is equal to 4, which means I know the slope of the tangent to the curve at x equals 3 is 4. If I wanted the slope of f of x at x equals negative 5, then I would just do f prime of negative 5. So again, using this answer that we got, that's going to be 2 times negative 5 minus 2. So that's negative 12. So now I know the slope of the curve at x equals negative 5 is negative 12. So by having the derivative in general, that allows me to plug in lots of different values to find the slope of the curve at many different places. Whereas the answer we got up here, when we got our answer of the slope was negative 8, that was only at one single point. That was at this point. But by having the derivative in terms of x, like I have here, now we can plug in any x value we want, and we know the slope. Okay, so go ahead. I'd like you to try this. So please pause your video, try example 3, and then when you're all done, press play, and you'll be able to check your solution. So for this one, we're going to say that f prime of x is, again, the limit as h approaches 0, x plus h, that's f of x plus h minus f of x over h is the definition of our derivative. And so for this function, that's going to look like this. We're going to have 3 times x plus h squared plus 1 minus 3x squared plus 1. Remember, this is f of x plus h, and this is f of x. And so now all we have to do is expand and simplify. And so if I expand the top, that is 3 times x squared plus 2xh plus h squared plus 1. All that's going to get, or sorry, this is going to get multiplied by 3, and then add 1, and then minus 3x squared minus 1 over h. So we have 3x squared plus 6xh. I'm distributing right now is what I'm doing, distributing this. And that is 6xh plus 3h squared plus 1 minus 3x squared minus 1 all over h. And we should have some things that cancel. 3x squared minus 3x squared, those are gone. plus 1, minus 1. Those are gone. Everything else has an h in it, so we can factor out the h. And so then that is the limit of, as h approaches 0, of h times 6x plus 3h over h. The h's cancel. And since h is approaching 0, this piece is approaching 0, we just get 6x. So that means our derivative function is simply 6x. Okay, and then a couple more demonstrations in Delta Math. So for putting in the derivative limits, they're just asking us to write the limit. And so for a problem like this, if we're trying to calculate the derivative at -7, a is -7, so it's going to be the limit. I'm going to put parentheses, and I'm going to put 3 in place of x. I'm going to write -7 plus h squared. So there's my 3x. Oh, sorry, that should be to the 5th power. So there's my 3x to the 5th plus x. And again, in place of x, I'm putting -7 plus h. And then I'm going to divide all that. Actually, let's see. That was only f of -7 plus h. So then we have minus f of -7. So f of -7 is 3 times -7 to the 5th plus -7. Getting a huge number there. That is -50428. 50428 divided by h. And then, so once we have that all set up, so there's our f of -7 plus h first, and then minus f of h, and then that whole thing, I don't really need this extra set of parentheses, that whole thing divided by h. So there's my f of a plus h minus f of a divided by h, and we'll submit and see if they agree. And they do. Okay, so notice how they just substituted in the -7. I wrote it as -50,428, but it looks like they would have accepted it if I just plugged in the -7 into the expression and left it unsimplified like that. That is acceptable as well. And then one more demonstration, derivative estimates from a graph. And so for this one, it says, which statement best describes the value of f prime of 5? So remember what f prime means. F prime means derivative, which also means the slope of the curve. So if we go to x equals 5, right here where my cursor is, we want to estimate what is the slope there. And the slope looks like it's a negative number. You can kind of imagine a line drawn like this that's just tangent at x equals 5, and that has a negative slope. So f prime of -5 would have to be a negative number because the slope of the curve, as we go from left to right, the slope of the curve is negative, and so f prime of 5 is going to have to be a negative number. If it was horizontal, like up here at 0, at 0, 3, there's a horizontal slope, that's when we would say the slope is 0 or the derivative is 0. So a slope of 0 means horizontal, or we have a negative slope, or we have a positive slope. And then remember we said at corners, like at -6 over here, the derivative does not exist at a sharp corner. So if they were asking about f prime of 6, we would say it does not exist. But in this case, at 5, it's clearly a negative slope. Okay, and that is it for today's lesson. Have a great day.